I'm Zoe Hubbard, and this is our group project on understanding electron charge. This concept is a major foundation in physics and plays a role in everything from circuits to automatic structures. So, what is an electron charge? The electron charge is a fundamental constant. It's always the same, about negative 1.602 times 10 to the negative 19 Columbus. It's super important in any topic that involves electricity. So this is Millikan's discovery. Robert Millikan discovered the charge of the electron in 1909 using the oil drop experiment. It was a major breakthrough and had won him a Nobel Prize. So how did the oil drop experiment work? In the experiment, Millikan used electric fields to spin tiny oil drops by balancing the forces. He found the charge on each drop was always a multiple of the same tiny value, the electron charge. So this is how modern day has confirmed it. Since then, more modern tools like quantum experiments and particle accelerators have confirmed his results. His value is still the standard for the electron charge. So you may be asking, why does this matter? Knowing the electron charge helps us understand how electricity flows, how batteries work, and how atoms are built. It's a piece of almost everything inside of physics. So this is our group project question. If an object has a total charge of negative 3.204 times 10 to the negative 19 Columbus, how many excess electrons does it have? So why is this useful? This type of question helps connect large-scale electrical values to individual particles. It helps students understand scale and the importance of constants in real-world physics. Why we chose this question? We chose this question because it's simple, but it still teaches something meaningful. We tested other ideas involving electric fields and forces, but they got too complex to explain well. What makes it different? Unlike typical textbook problems, this one pushes you to really think about what charge means. You're not using a formula, you're connecting math to actual electrons. Background info table. This table shows how charge increases with more electrons. It's a straight line relationship since each extra electron adds the same charge. Negative 1.602 times 10 to the negative 19. This visual helps you see how the formula works. Now this is the formula breakdown. We use the formula Q equals N times E, where Q is the total charge, N is the number of electrons, and E is the elementary charge. To find out how many electrons, you just divide Q by E. Now this is how we solved this step by step. So we plug the values Q equals negative 3.204 times 10 to the negative 19. E is negative 1.602 times 10 to the negative 19. When we divide that, we get 2. So the object has 2 excess electrons.
All right, let's solve it. So we're given a total charge of Q equals negative 3.204 times 10 raised to the negative 19th power C. One electron carries E equals negative 1.602 times 10 raised to the negative 19th C. So the charge is quantized, so Q equals NE. Rearranging gives N equals Q divided by E, which is equal to negative 3.204 times 10 raised to the negative 19th power divided by negative 1.602 times 10 raised to the negative 19th power, which reduces down to 2. The negatives cancel, so we have 2 excess electrons on that object. Second, our work. Doubling the charge should doubling the elementary charge should double the total charge. Our Q is exactly 2 times E, and N came out as a positive number, which is essential since you can't have a fraction of an electron. Uh, this is relevant to the topic of the electric charge quantization, which is a core concept in the physics. Fun extra fact, Millikan also worked on cosmic rays and was one of the early American science communicators. He helped people understand science in simple ways. What surprised us was we thought figuring out electron charge would take crazy math or computers to accurately, uh, compute. But it was actually done over 100 years ago with oil drops and just careful math. A summary. This project helped us learn how electron charge was discovered, how it's still used today, and how we can apply it in real world problems. Also, it was cool to kind of build our own question with it. And these are the sources we used for our project and for some of the images.